If you need help with grade 11 vectors in 2 dimensions, this video is for you. 1.1 says, which of the following is a scalar quantity? Options were given as A, B, C, and D, being force, velocity, acceleration, and speed. So as we look at this here, we can tell that force is not going to be one of the right answers because force is a vector, of course. Velocity will not be one of the answers because velocity is also a vector. Acceleration can be a vector or a scalar, but in this case, they want us to give a definite answer. So acceleration will not be one of the answers because acceleration can also be a scalar, which leaves us the one answer, which is speed. Speed is essentially going to be our scalar quantity. If you got D, give yourself a round of applause, give yourselves a fire emoji in the comments. If not, don't stress, there's more questions for you to try and improve. Let's jump to question 1.2. 1.2 then says, the objects below are all identical and resting on frictionless surfaces. Which object will experience the greatest acceleration? We have options A, B, C, and D. This question might seem a bit tricky when you think about it, but it isn't that bad. How do we approach it? The key thing is to figure out what our resultant force is, and the biggest resultant force will experience the biggest acceleration. It doesn't matter which direction the resultant is, as long as we're looking for the biggest magnitude of the resultant. So let's look at A. We've got 13 minus 10, and we're going to minus them because they're acting in opposite directions. 13 minus 10 is going to give us 3, and the 3 is going to be to the left, so we know that that's not going to be one of our answers that we're looking for. Then we're looking at B, which is 12 and 12, that'll give us 0. C is going to be 7 and 2, so that'll give us 5 towards the left. And then D is 20 and 24, that'll give us 4 to the right. So we can very clearly see there that now C will give us the biggest resultant, which is going to be 5 newtons to the left. So your correct answer there will be C, meaning that A, B, and D would not be the correct answer. Awesome, guys. Those are the 2 multiple choice questions we'll do for this lesson. And I want to remind you is don't just pick the answer that you think is the right one and move on. You need to give yourselves the right reason why the other answers are incorrect, and then you can move on past a multiple choice question. Awesome. Let's do a structured question now, looking at an equilibrium problem. Question 2 then says, a light string is suspended from the ceiling X. An object of mass 8 kilograms is tied to the string at O. A horizontal force of 60 newtons is exerted at point O, causing the string OX to experience a tension T as shown in the diagram below. The system is in equilibrium. Awesome. So we need to now unpack all of what they're telling us in this case here, right? So we can see that we've got this point X they're referring to there. This object here has a mass of 8 kilograms and it's tied to the string at this point O there, causing string OX, this is string OX there, to experience a tension, right? T, and there's the T, there's a tension in that cable there shown in the diagram. The system is in equilibrium. Equilibrium meaning everything is going to basically have a 0 resultant in that case there. Let's look at the questions that follow. It says explain the term forces in equilibrium in words. That's nice and easy one. So what we can simply say there is forces in equilibrium when the net force acting at a point is equal to 0. So forces will be in equilibrium when the net force acting at a point is equal to 0. Super easy, super chilled. Let's jump to the next one, 2.2. 2.2 then says draw a closed vector diagram showing all the forces acting at point O, indicate the angle theta on the diagram. So what we need to do is take all the forces we've got acting there and bring those forces down and draw them in a closed vector diagram. The reason why we can have a closed vector diagram is because we are at equilibrium, meaning we will have a 0 resultant. Where we start off is where we're going to end up at the same time. Okay, so for question 2.2, what we want to do is take all of our forces and draw them head to tail, and we're going to arrange them into a triangle. And this triangle should then close up essentially. That's why it's a closed vector diagram, because we've got a net resultant of 0. So essentially, let's start with our FG. So we'll have this vertical force coming down like this. This will be our FG. And then we know at that point there was a horizontal force, the 60 Newton force there that's acting from left to right. So I'm going to draw that straight from the head of our FG going horizontally to the right. That's our 60 Newton force in this direction there. Finally, we've got our tension force, right? So this tension force is acting diagonally. Now, what direction will that tension, thinking about point O, so at point O, the tension is pulling upwards into the ceiling, right? And then we can then draw that force there, upwards, like that. into the ceiling. This is our tension force. They said we must indicate the angle theta. Now what I want to show you guys there is the angle theta is the angle between our tension and our vertical. So this angle over here. So all I'm going to do is find our tension there and a vertical there, and I know that this is my angle theta, so I can plug that angle theta there. Simple, easy, nothing too hectic. Awesome, guys. Let's jump on to the next question. Question 2.3 then says, calculate the magnitude of the tension T in the string OX. Now, often when they give you questions like this and they ask you to draw the vector diagram, that's always a very good hint, because this means you don't have to actually go and resolve forces. Take the vector diagram, which will usually be a right angle triangle, and you can now do trigonometry. And trig is going to be way easier than trying to resolve a bunch of vectors. Okay, because when you look at this diagram here, this is a right angled triangle. You've got theta there. This corner here will be 90 minus theta, and then you can use sine, cos, or sine, cos, or tan to figure out any other value that you've got. Key thing we need to figure out is FG, but we do know that we've got an 8 kilogram weight there, so our FG is going to be 8 times 9,8, which will give us a value for that. So we've got the value for the vertical, the value for the horizontal. We can use Pythagoras to get the value for the tension force. So we will do that. And very important, they asked us just to find the magnitude of this tension force, meaning for now, I don't have to worry about the direction. So I can simply just use Pythagoras to find that answer. So what we can simply do there is say, well, in that right angle triangle that we've got, we are going to start by, let me quickly get my pen there. We're going to start by finding the tension force using Pythagoras. So we know that my tension squared is going to be equal to the sum of the other two sides squared. So that's going to be equal to my Fg squared plus my force of 60 newtons squared, right? And now I can simply substitute values in and then get to my final answer. So then my Fg, I said, is going to be mg, which is equal to 8 times 9.8. That's going to be mg squared plus the force of 60 newtons squared. Let's substitute our values in now. That's going to be, my mass is 8 kilograms. Gravitational acceleration is 9,8. You square all of that plus our 60 newtons squared. What you'll see if you plug this into your calculator is you should get an answer of 9,746,56. This is not our final answer because this is the value for t squared. What we're looking for is tension, so we have to square root this answer. So in square rooting both sides of this equation, we'll square root there and square root there. Our final answer, what we will find is that tension T will be equal to 98,72 newtons. I don't need to give a direction because they simply asked for the magnitude, not the value or calculate the force of tension. Next question, 2.3.2 says, calculate the angle theta that the string OX makes with the vertical. So what we can see there, the angle theta is this angle here. We now have Fg, we've also got 60 newtons and the tension. We can use trigonometry to find the angle. My golden rule is always use values that are given to you rather than values that you have calculated. Because if you made a mistake calculating t, you'll make a mistake calculating theta. So I'm going to use Fg and the 60 newtons, which gives me less of an opportunity to make the mistake calculating theta. So in this case here, let's try to think about our trig ratios. From theta, this is the opposite angle. This is the adjacent angle. Opposite and adjacent, we're going to use tan, right? So we can simply use tan. Let's jump straight in and use tan there. So we know that tan of theta is equal to my opposite over my adjacent. So my opposite is going to be that force of 60 newtons or my F applied. My adjacent is simply going to be my Fg or my weight. Now I can substitute the values in, where tan theta equals the 60 newtons divided by my Fg is 8 times 9,8. And then I can simply arctan that to get the answer. So I'll say theta equals arctan or tan inverse, right, of 60 divided by 8 times 9,8. Plug that into your calculator and you should find an answer of 37.43. And don't forget your units, it will be in degrees, all right? Super easy, nothing hectic. Let's look at 2.4 together. 2.4 then says, without doing a calculation, write down the magnitude of the resultant force at point O. Quickly see if you can put your answers down in the chat before I'm done with my solution. Now let's quickly come back and look at this question and see what happens at point O. There's a very important part that we were told about this question, and the important part is that the system is in equilibrium. What did I say about equilibrium? It means my F net equals 0. There's no resultant force acting on my system, particularly at point O. So when we come back to the question asking us, without a calculation, the magnitude of the resultant force at point O, well, we know that F net at point O equals 0 newtons. Super easy, nothing challenging. This is us at the Learning Space, making science super fun, super easy, and not a challenge at all. Please join us on our YouTube channel and follow us to go check out more videos. Subscribe to our TikTok if you haven't, and we'll see you guys in the next video. Cheers.